I see we still have some people filing in. We'll give them a couple of minutes. We're starting here probably in about 1 minute. So thanks everybody for coming. Appreciate your attendance, and we'll be getting started just in a few seconds. Thanks. Also, I do notice that if you have questions as we kind of go through the presentation today, we only have about an hour together. So let's just kind of be respectful of that time. And my goal is to do a bit of lecture, a bit of a demo, and then leave some time for questions. So with that being said, probably won't have time to do questions as we go through as far as interrupting type questions. But if you have a question, I can certainly just look over to the chat window and look at it. And if it's something that I'm going to be talking about, or it's something that I need to address, I'll be sure to address all of those before we drop today. So please use the chat window to interact with us, and that'll be your method for communication. With that being said, I know there's probably a little bit of housekeeping that needs to be done, maybe by Colette from the staff at Arkansas. So if they want to go ahead, I'll turn the mic over and give you that opportunity.
Nothing from us particularly here at the U of A. We just want to thank you and Colette for organizing this, and we're very excited. We have students that will be joining as soon as they can, if they haven't already, and we will have this recording available to everyone who may be in class currently. So Tommy, if you could just make sure that we're recording, that's all that we ask, but we're excited to hear what you have to say. Thanks for coming.
Thank you. And yes, hi everyone. I'm Colette, also from Simba Chain. Tommy here is our master trainer, so he'll be leading this workshop. But if you have any questions, like Tommy said, feel free to drop them in the chat as the presentation goes on. I will check them periodically. And also any resources or anything, I'll also be dropping in the chat. Okay, thank you. And I'll toss it to Tommy.
Awesome. Okay, let's go ahead and get started. I know we have a limited amount of time together. And first of all, I'm so excited for you guys to be participating in the hackathon. I'll just tell you quickly one of my stories about coming to Simba Chain. It's kind of a fun story. I had found myself at a blockchain company and had left that company and wanted to just do hackathons. And I asked the folks at Simba Chain if I went to hackathons and promoted their product, would they pay for my travel? And that was about 3 years ago, believe it or not. And so here we are 3 years in, and the company has grown by leaps and bounds from just a handful of people to almost 100. So with that being said, let me go ahead and do some quick introductions. As I just mentioned a little bit about Simba Chain, it's not what you would think of when you think of a traditional blockchain company. Simba actually has a really interesting background. We were started from what's called a DARPA grant. And if you know DARPA, that was kind of the same thing that started the internet and a lot of really great technologies. And what happened was there was a request to do secure cryptographic messaging on unsecured networks. And so imagine, if you got to communicate on an unsecured network, but you got to use different devices on that network, you want to be able to make sure that you can't get your medium can't get kind of defeats your purpose of the messaging, right? You don't want people listening in on your communication. So so we created Crypto Chat, and that's pretty similar to a lot of things that happen in blockchain. So the company then decided to start a blockchain company. And here we are 4 years later with multiple contracts to integrate blockchain technology for both enterprise and Department of Defense and government and things like that. So that's a little bit about Simba. Myself, as I mentioned, I'm a trainer, guys. I've been teaching IT and technology for almost 30 years. Got lots of certifications, cloud certifications, ERP type certifications. I'm a PeopleSoft full stack developer, and I'm an AWS professional architect. So, and I'm also a security specialist on AWS. So there's a lot of certifications that I have along with blockchain certifications. But one of the things that really makes me attracted to Simba is it allows you to follow and the appropriate workflow in order to get the results out of a technology that you need. And it makes the tools to get there really, really easy. And so instead of having to learn a new programming language with like Solidity, you still might have, somebody is going to have to learn Solidity probably, but you don't necessarily have to everybody learn Solidity. So you can start to appropriately use the tools in order to get the results that you're looking for. And I'll explain that a lot as we go through this lecture. So really what we're going to be looking at in the lecture to try to kind of get everybody to get kind of on the same sheet of music and understand where we'll see a lot of really great opportunities in blockchain is we're going to go in and we're going to look at how data in IT kind of flows, and then how there's been some pain points that we haven't been able to fix traditionally, and then how blockchain can address that. And then we'll talk about when we want to do that, we don't have to kind of throw the baby out with the bathwater, which is what we would be thinking of if we retrofit or rebuild everything from scratch. We can maybe retrofit what we already have and talk about how Simba tooling allows you to do that. And that allows you to kind of take an idea that you have and turn it into a proof of concept. And that's really ultimately, I think, what you want. You don't really need to have a minimal viable product for a hackathon. You need a proof of concept that works really well and it solves a problem. So often you'll hear people say, add friction and remove value. That's what you're looking for. You're looking at workflows and you're trying to figure out, how can I use this technology in order to add value to that workflow or remove friction, right? So either of those usually will create winners. And so, when we think of laws of thermodynamics, we try to look for energy that is being created that instead of just being disposed of, somehow could be used as an input somewhere else. And so you start thinking that way with blockchains, you can start to think about how you can digitize your data and make your data valuable. So let's kind of speak to that a bit. Before I get started again, is there any questions about our introduction? Or anything before we get started? Is everything going okay? Sounds coming through for everybody? We all good? Okay. All right. So before I get too far ahead of myself, if anyone knows who Marc Andreessen is, I will mention that Marc Andreessen is the founder, or excuse me, the lead designer of Mozilla Netscape. So kind of one of the very first browsers that allowed us to do documents on the internet securely through cryptography. Pretty cool, huh? Anyway, he wrote an article back in 2005, was published in the Wall Street Journal, and he talked about how software as a technology is in essence democratizing workloads. Whether it was when Bill Gates sold software for the very first time to IBM, or it was when Netflix kind of eviscerated Blockbuster, or when Pixar kind of made itself so relevant that Disney had to buy them. Borders overlooked Amazon. AWS as a service kind of has taken over a lot of IT companies, right? And so cloud-based services, people don't want to manage servers, they just want the tech. And so that's really one of the focuses of Simba, is we just give you the APIs that you need in order to get the tech that you want. And so when we start thinking about Uber, that beat the taxi industry and Airbnb and lodging. So ultimately the point is that technology is used in order to fix the problem. Well, the big problem that we generally have is a trust problem. And I want to talk about this trust problem. If you're a technologist or if you're an IT person, you're probably very familiar with some of these cryptographic methods that I have listed here. But generally speaking, the point that I'm trying to make is that we use cryptography in order to mitigate the risk of trust. Okay. I'm going to put a link in your chat window. It's to a Medium article that I wrote. And I want to kind of draw your attention to this because I think this helps tell the story. But when we start thinking about what the internet is, we really need to understand kind of it and define it, and then define what the web is and how the web has been progressing, so we understand where we're at and know where we're headed. And so when we think about the web was really difficult. When the web was first kind of in the pre-Mozilla days, if you wanted to have a web presence, then you had to have a server. You had to have connectivity that was provided from a provider that was providing you with some type of a data line, or you had to have an analog line that was using some type of a modular demodulation, a modem, in order to be able to communicate, right? Believe it or not, we use these modems that we would dial up with. And so in order to be able to have a network of communication, it was very hard. It was expensive. It was a destination point. My connection to the internet, first time I ever got connected, wasn't going through AOL or wasn't going through some provider. I had to go to my squadron in the United States Marine Corps and log in and get access. And I wasn't looking at cool pages and cool things. It was very clunky. And so it was hard. It was very expensive. And it was a destination point. It wasn't ubiquitous. It wasn't just something that's in your pocket. And everything was relatively read-only. So what do we need to do? What is the problems here? Well, the problem is it's not normalized. Any sufficiently advanced technology, we've heard Arthur C. Clarke say that it's indistinguishable from magic. And the reason it's so magical to people is because they just don't understand it. We have to wrap our head around the idea of what's happening with this technology before we can start to adopt it. And so that's what the internet was. It just wasn't, nobody really got it. And so there was a lot of very much just read only. It was digital bulletin boards that you could just go and consume information, but it was really hard to be your own publisher. So when we think about normalization of technology and how that technology needs to get normalized, maybe a good example of that would be the automobile. When the automobile was first introduced in the turn of the century, it had to be normalized in order to drive this crazy contraption on on busy streets. For instance, like in New York, you had to have a 3-man crew. You had to have 2 flag wavers and a mechanic in case this thing broke down. Another big, opponent of the car and the technology was the people. They didn't want to lose their jobs to this thing. So if they were shoveling manure, they would definitely lose their jobs, right? And there was actually different unions and employment that employed people who shoveled manure for the city. So obviously they needed to be retooled. They had to retool themselves. It's not appropriate for us to bypass the technology of the automobile in order to allow that manure shovelers guild, for instance, to survive. So we have to make the appropriate engineering choices, right, along the way. I think it's important to do that. So when we start looking at current factors of the web and where we're currently at, the thing that we're going to notice is that Web 2 has really concentrated on fixing this normalization problem, but it created a problem by itself. And that problem was it centralized the power. And so now what has happened is this power has become very centralized onto the platforms. I used MySpace as an example because it really was kind of one of those first digital platforms, but Facebook, Twitter, eBay, Craigslist, YouTube, the list goes on and on. We've seen how when we want to do a certain thing, that's where we go. We don't go to the periodicals in order to buy something. We go to Craigslist or eBay. If we want to look for a job, we look on LinkedIn. So what we've done is in essence, we've started to centralize the workflows, which has also centralized the data. And so by doing that, that has created a level of power where we didn't realize it was happening. And probably the first time that was started to really become apparent was in our last president. So this is not political at all, but whether you're on one side of the fence or not, if you can silence a nation state president from being able to voice to their population through that medium, because that medium is the chosen medium of the population, then that might be something that needs to have some level of governance associated with it, or some level of decentralization. And that's in essence what we're looking at with Web3. Instead of putting the governance in a centralized body that can say, I'm Jack Dorsey, and I'm not going to let you communicate on Twitter anymore. And I'm not picking on Jack. Jack did not do that, actually. It wasn't him that made that choice. It was his board of directors. But the point is that centralized power creates the ability for them to make profitable type decisions. And so that isn't always in the best interest for the public. So when we start to think of things that should be like public goods, these are very low hanging fruit when we start thinking about their ability to become a protocol, right? Instead of a platform. And so what we're trying to do with Web3 is do just that. We're trying to build financially incentivized protocols that allow us to remove that layer of fraud, that layer of distrust. Remember we said earlier, we want to mitigate that risk of trust. That's kind of what we're trying to do now, because we've lost trust. We started to put the trust into the platform, but the platform has lost our trust, and so now we have to figure out how do we continue to have the same functionality, but not necessarily have to trust the platform. So that's in essence really what the web was intended to be. And this is kind of a fun story. I'll share it with you. It looks like we're doing pretty good on time. So this story talks about a gentleman by the name of Sir Tim Berners-Lee. And if you don't know who he is, you can click the link there and it'll take you to his, I think it's his Wikipedia page. But Tim Berners-Lee is the gentleman who created the protocol that allows us to link all these documents together. So remember, we said that the internet was all the wires and the connectivity, and then the web is the documents and the things that we put on top of it and allows us to share it. And so when those documents were centralized and controlled by those central authorities, then those became gatekeepers, right? And so with Web3, we want to kind of maybe start to remove some of those gatekeepers, but start to create protocols that allow the functionality, right? And so there still might be gatekeepers, but they're based on the protocol, not based on opinion. And so, with that, that's building what we would consider a semantic web, right? Or a web where you can have ownership of data. When we think of the Web 1, a lot of people will say Web 1 was historical and it's where we used to be, but it was read only because everything was just kind of put up there for us to consume. Well, what happened was with Web 2 is it created the capability for us to be our own publishers. You can go in and create your own website. You can create on Wix. You can go in and be your own video publisher on YouTube. You can be whoever you want to be and write your own blogs on Medium like I do. Whatever it is that you're looking to do, some of the barriers to entry that were found previously have been removed by some of these platforms. However, what we've done is we've donated not only our content to these platforms, but we've also donated power and centralization of that power. So we have to kind of try to figure out a way to mitigate that risk from a protocol level. And that's what a lot of times Web3 can be thought of as, and really what blockchain kind of helps us to do. And so when we think about this gentleman again, Sir Tim Berners-Lee, what he set out to do when he invented the first version of the web is he wanted the web to be semantic. It wanted to be self-managed. It wanted it to be self-sovereign, right? You have sovereignty involved with data, but it just didn't have the tech to do it. As a matter of fact, the tech was almost opposite of that. And I'll give you a great example. if you were to take something of value and put it on this thing, this internet thing, that thing that had value before probably wouldn't have value very long. Think about the music industry and Napster. Think about the movie industry and being, Pirate Bay, right? And so all of these underground sharing of media created the ability for the double spend problem. You might hear the term Byzantine general problem a lot, but it's basically the same thing. It's the ability for the thing that's a digital asset to be easily copied. And when it's copied, then it robs that thing of its value. And so with blockchains, what we've done is we've baked cryptography into the code so that the data has digital scarcity to it. A certain level of digital scarcity depending on the network size and trustability and things like that. But generally speaking, the code gives us the ability to layer in that trust using the cryptography that we talked about a minute ago. So it, in essence, takes that read-write web and allows us to now have ownership. So now you can start to think about, well, what kinds of things that are digital might I want to actually own? What kinds of things that I maybe want to just follow me for the, be soul bound, is what Vitalik Buterin, the founder of Ethereum, talks about. But soul bound, meaning that it just follows you for your whole life, right? So if you get a degree, that's your degree. And it should follow you for the duration of your, for your education, should follow you forever. So, and it should have the value, the digital value that you can prove and you can have ownership of, instead of having to go get the transcript and the transcripts get sent. We can check digital signatures and things like that. So things along those lines are different ideas that a lot of people will come up with in order to look at starting to package digital information together. And when we do that, what do we call them? Well, we call them tokens. And so that's when we start to talk about a non-fungible token, something that's not the same as somebody else's, or something that is fungible. And usually the difference is that a non-fungible token usually has something to do with some claim and verification of the claim. And a fungible token usually has to do with the utility. So if you want to get utility out of a system, using the token, just put it in and it gives you the ability to do something, that's a utility token. If you want to be able to say, hey, this is me, or this is my education, or this is my CryptoPunk, or my Bored Ape Yacht, or whatever it is, then that's a non-fungible token. So in essence, what Web3 did for us is it just gives us this ability to have this ownership of data. And with that, you can start to take a look at these workflow processes. Like I said, look at those friction points, right? Gatekeepers to like payments, for instance. A lot of times a farmer takes forever to get payment after they drop their crop off at a co-op. And that's what our Tokes example does for us, is it allows that farmer. I think we have a case study where it shows that we've increased their income by 700% in the Yucatan area, where the farmers are growing the coffee that we're tracking on a blockchain. All the way from the coffee grower, all the way to the cup. We track it and we keep track of what's happening. So with that and those data points, we can start to get a lot more insight. So whether there's a problem or if we want to do a reward, there's a lot of interesting things you can start to do. Okay, so it gives us kind of transparency in all this transactional data, and then the data about that data. And that's really important, like who did what and when did they do it? We just came through the COVID vaccine and we all know that when those vaccines were being handed out, that they had to maintain a certain temperature. Well, a lot of different handlers had to handle those vaccines before they got to the clinic that distributed them. And so how do we know that the temperature was maintained? Well, we could use a blockchain to do that. That's an example maybe where data about data is really important. What do we usually call that? Well, that's called metadata. That's actually the definition for data about data. But metadata is, in essence, what we're doing is it's just data points about information that allows us to marry what's going on in the real world with what's going on in the digital world. If you've ever played Pokemon Go, you probably have a pretty easy understanding of the metaverse. If you've not, then it might be more difficult for you to understand. But the metaverse is just taking digital information and then using that to help to enhance your real world experience. That's it. Instead of engaging a screen and a thumb in order to get to the thing that you want, you can just do it ubiquitously. There's sensors, there's something that's doing it for you. Maybe it's your phone that has all kinds of sensors built into it. And so with that, we can now think we can have ownership of our data. You know, I thought when I was many of yours probably age or around your age in the early 90s, when the internet first got started, I thought that this was the technology that I had to learn in order to really kind of pole vault my career. And I'm really glad I made that choice. 30 years later, I wouldn't change it. I would say that something that I've noticed in my time doing what I've been doing is that this technology is the only technology that I've seen, whether it be distributed databases, whether it be JSON, document-based databases to relational databases, communication methods, 5G. This is more disruptive. This is the disruptive technology. And I feel that way because, I'll give you a great example. And it's this light bulb tells a story. But if we think about electricity was around for almost a half a century before the Chicago World's Fair, when the light bulb actually was shown to the world. Before that, electricity was used in carnivals for tricks. It was used for Morse code, but it wasn't heavily adopted. It wasn't normalized. I would make the argument the internet still isn't normalized. There's still millions of people that aren't normalized as far as the internet is concerned. Why? Because they have no interest in having access to this information. They don't even have the ability to bank themselves yet. With this technology, literally one of the things that they talk about is banking the unbanked, giving the ability for the people that are unbankable, that might live in an area where they can't trust their bank or their government, and they have no ability to leave. How do they store their value? How do they do this, right? And so, they store it in Bitcoin a lot of times, right? And it's like a lot of people will say that Bitcoin provides that store of value mechanism that many times money can't do. And so, or currencies, I should say, can't do. Money should always do that. Anyway, so that's kind of what we talk about when we think about ownership of data. It's really, I think, in my opinion, we're 40 years in, about the same time with electricity, we're really starting to understand the importance of our ability to do this mass communication. Well, the importance isn't that we can just communicate. The importance is that we can exchange value amongst ourselves, and we can make our own decisions. Community, and we can create communities and do that digitally. And so what kinds of applications can we build on top of that? I think that's the floodgates that we're opening. And so I'm going to go ahead and turn back to my slideshow over here. It's this one here. And so, when we start to think about this, you'll see the focus now is going to change a bit from not so user focused to more technical focused. So if you're a technical person, this is more focused towards you. So anyway, when we think about trust, this just talks about some of the standard mechanisms that we use in cryptography. Basically, it breaks down to hashing, encryption, symmetric and asymmetric encryption, right? And so that basically just is these really big numbers that we use in math in order to prove things, and we've been doing that forever. And the cool thing is that when we do this with the blockchain and the smart contracts, it allows us kind of take a lot of the things that we might have done previously as a bolt-on effect, and instead bake it into our workflow. And what does that then do is it kind of normalizes the technology and democratizes it and somewhat makes it easier for everyone, right? It removes that cost. So let's kind of look at some of the workflows here. And this is why I said this gets a bit technical. So if it does too technical for you, I'll try to make this as simple as possible. What you're seeing here is in the front end, this is the web server. In the middle tier is what we call the middle tier or the app server. And then in the back end is usually what we consider our data store, or basically where we're storing all the information, stuff that we want to keep around for a while, right? And that's usually a database. And so where are we making this big disruptive thing that Tommy's talking about with the blockchain? Well, it's really happening kind of here and then somewhat happening here. So the middle tier and then the back end, and I'll explain. Traditionally, the back end data structure was on a database, and a database has a data structure called CRUD. It stands for create, read, update, and delete. Now, those are the actions that you can perform on that database. You can create something, create a new record for you. Maybe it's your pay record. You could delete it. Maybe you weren't making enough money. You could update it, say, hey, I'm making a 50% pay raise. Or you could write a new one, right? Just create a new record and say, this is the record that replaced the old record. So create, read, update, and delete. And so what is the problems there? Well, the problem is that those updates and those deletes, they really cause us some pain, from a design standpoint. So what we have to do if you're a data designer, is you have to look at your data store and think which pieces of my data store are structure and which pieces of my data store are contextual. If it's structure, then it's defining the workflow. It's defining how things should happen no matter what's happening at this particular transaction. It's just the workflow. It's going to do the same thing every time somebody rents a movie at Netflix, for instance. Or when it does it for you, then it puts that into your viewing history. But that's your instance. So what's the difference of the data? Well, the structure, the renting of the movie, is ephemeral, meaning that it doesn't change. The renting of the movie is the same for me. It's the same for Chance. It's the same for Caden. It's the same for Catherine. It's the same for Annabelle. It's the same for all of us guys. And so when we look at the structure, that should be ephemeral, meaning that it's the same structure for everybody. We all follow the same rules. That sounds like a smart contract to me when I start thinking about Web3. And that's what our system allows you to build. So start thinking about those structural pieces that you feel like are important to you, that you want to keep track of on a blockchain, that you want to have that immutable characteristic that we talked about before. Oh, immutable characteristic. Well, what kinds of things might I want to have an immutable characteristic on? Well, I'll tell you something that probably you would want to have an immutable characteristic on is anything that was a transactional transaction, right? So content should be immutable, right? So those transactions that occur through that structure should be immutable, so that you know that, oh, well, that was this person that rented that movie at this particular date and time, and it came from this IP address, and it came from this geographical location, and this is all the metadata that we have around that particular renting of that movie off of Netflix. Okay, who owns that? Well, right now, Netflix does. You should probably own it. Maybe Netflix could leverage it, but that could be negotiated through your contract with Netflix on a case-by-case basis. It shouldn't be something that should be just owned by the platform. And that's kind of where you should start thinking. That's kind of what we're looking at here, right? So we're trying to figure out, how do we separate structure and content so that we own our content? It's part of the data set that's immutable, but it's just an NFT, right? It's just a non-fungible token that in reality, it's just an index. It's actually an index to some actual data that probably exists in their platform somewhere, but based on our agreement, we have only access to it for a certain period of time based on that contextual agreement in that contract, right? Smart contract. So, wow. So that means that this is back-end data store got kind of smart, didn't it? It kind of did. Yeah. And it has a financial element along with it as well, because this cryptography takes up a lot of computing power. And so in order to kind of mitigate that, in order to make sure you don't have bad actors, then we use gaming mechanisms. That's where you'll hear about consensus. But basically, we use things like proof of work, proof of stake, in order to make sure that those that are writing the data are doing it in an honorable way, and they're not trying to break the system or game the system in any way. So that's how the protocols are generally supposed to work. And that's where we see all this big disruption is back here on this back end data set. Now, a lot of times we're not so much talking about blockchains. A lot of times people will confuse blockchains with Web3. Well, blockchains is just a piece. It's just, Web3 is the big lake, right? And a blockchain is just kind of like where you dock your boat, right? Or it's a piece of the pie, right? But the blockchain is just this little piece back here that's interrupting the data store. But if we think about, like I mentioned earlier, you have the middle tier and the front end as well. Well, the front end, we already said that the screens and the thumbs are our pain points. We want ubiquitous computing. We want sensors to tell us information so that the machine can tell us what is the conditions right now. And if I can do that, then I can pass that information to another machine here to make that decision on that information and maybe make a more accurate decision. So when we start thinking about ubiquitous computing and machine learning, that's where this middle tier and the front end are going to get really disrupted. They're already getting disrupted. And when we start thinking about the ability for us to interact with them, well, we don't have to engage with a screen or with a keyboard. We can just use the sensor, whatever that might be. And we can start to then take advantage of that with alternate reality, virtual reality, all kinds of things that we can start to realize through this workflow. So lots of opportunities here. And what kinds of opportunities? Well, everything. I mean, literally everything. I'll give you an example. Do you think that trash won't get affected by this? Well, I'll tell you an example where trash could get affected by this. IoT sensors placed as input devices in dumpsters. Those IoT sensors then sense whether or not that dumpster needs to be emptied. They also integrate that with an algorithm to figure out what was the last time that particular dumpster was visited, to make sure that it gets visited on a certain schedule in the event that the sensor's broken. And so now, instead of emptying bins that are empty and wasting gas and putting a bigger footprint, we can create more optimal routes, and the routes aren't the same routes for those waste distributors, and the waste distributors can create a marketplace for bidding on that waste product. And this happens actually in a big metropolitan city. I can't really talk about it too much, but that's a marketplace. That's pretty amazing. There's some fun things that you can start to do with data in order to be able to mitigate a lot of the risks that we had, or the problems, the waste that we've had in the past. How can we optimize our workflows? How can we create better public goods? Those are things that you probably want to start thinking about. So when we look at the blockchain, the first version of the blockchain, it was just about kind of Bitcoin. If you don't know much about Bitcoin, it really kind of just solved this big store value problem. Created a ledger. We call them distributed ledgers in computing, but it used this thing called DLT, distributed ledger technology, in order to be able to encrypt rules into that ledger that make sure that the data is not going to change. And it'll keep track of that data, and that data just keeps track of these things called Bitcoins. Those Bitcoins are economic incentives for anyone who has contributed to the network. So when those that had contributed to the network get rewarded, they get rewarded in the form of those Bitcoins, which then they can sell them for their investment of energy and time. And usually that's in the form of mining. That's why you hear the term mining. But that's basically computing power and hardware that is being used in order to solve a really hard math problem. That's it. That's all it's doing. And once it does it, it just yells bingo to give me my reward. And so again, it's just a ability for us to keep track of this thing that stores value. Well, think about that for a second. What's kind of cool about this that's not cool about maybe fiat currency? Well, what's cool about this that's not cool about fiat currency is that this particular mechanism has a monetary policy that would require the whole network to agree, or 95% of the network actually, to agree to change it. So that's different than what we see with, like, for instance, the Federal Reserve. They've printed a lot of money over the last couple of years in order to keep us afloat. So when they do that, that affects anyone that holds that money, because it makes the money that they're holding less valuable for buying assets. So and it reduces their purchasing power. So in essence, moving the decimal point to the right kind of takes away from any current holder of an asset, because you're increasing the asset and decreasing the value of the scarcity of the asset that already exists. When you move the decimal place to the left, which is what the design of Bitcoin is instead of creating more, we just tap into its ability to be fractionalized. Instead of only going to 2 decimal points, which is what we do with the penny, to the dollar, we can go 18 decimal points, which is a Satoshi to a Bitcoin. And so that is kind of the difference in the monetary policies, is they just say, well, there's only going to be 21 million, and the value is a deflationary currency. So there's not going to be any more. So if the market continues to rise, then the value will rise just based on supply and demand. And so that's why you see a lot of the people say, oh, it's a Bitcoin millionaire or whatever, but that's how it happened. And so what happened is there's this guy, his name's, you'll hear me talk about him, his name's Vitalik Buterin, but he was a writer for Bitcoin Magazine, actually, and he wanted them to expand this ledger that they had. So here's the important thing to think about with the ledger is just storage. It's just that back-end storage that I just talked about. But what we wanted to do is we wanted to add compute on top of it. So for those of you that are IT majors, we want to be able to actually solve problems by passing them to some type of a virtual machine, and that virtual machine will then handle that logic that we pass to it. Okay, pretty simple. But this virtual machine is not a virtual machine that I'm spinning up on just my machine. It's a global virtual machine that we come to consensus on. That's what you got to wrap your head around, right? So now we have a global singleton machine that can maintain state on an asset. What? I'll say that again. Now we have a global singleton machine, which means that it's a global machine that maintains singleton state of an asset. Whoa, that's kind of cool. That's what you get with Ethereum and Solidity, right? So what is that? Well, Ethereum is just this virtual machine. It's called the Ethereum Virtual Machine, or the EVM, that runs code and allows that code to be interpreted then in order to be able to create smart contracts. And so that brings me to what we do at Simba. We try to make this really simple. We say, you know what? We're not going to worry about all of this crazy stuff that you got to do. We just want you to worry about 2 things, right? And I'm going to show you what it is. I'm going to open up I'm starting to run out of time, so I need to open up my demo here. But when we come in here, and this is at app.simbachain.com, so I'm going to put this also in your chat window. And then also we can provide you with a tutorial that will walk you through kind of creating that coffee to cup application that we had talked about. I can share that with you if you want to use that to kind of get familiar with this. But basically what we do here is we create our identity through our wallets. And then after we create our identity through our wallet, which is just this private, public and private key here, we then fund it through one of the different token networks. And keep in mind, this is for testing and proof of concept. This is not for production. This is not a production tool. This is a wireframing tool. Okay, this is not a tool that you want to use for building your end-to-end app. We have an enterprise application for that. This is just for mockups. It's perfect for these hackathons. But we do all these test networks that are available to you. And we even have this Circle of Life network, which is a testable network that we run for you. And then you can fund the wallet, and then you can come in here to your smart contract. And this is the beauty. Watch this. If I go to create a new smart contract, this is where you start. Wait a minute. Well, there's only 2 page controls in here, Tommy. There's only this add asset and add transaction. And then there's just stuff down here to like validate the contract, save it and quit. And then all this junk over here for like permissions or something. Yeah, you're right. But look at this. What did I just mention? We want to own something. What do you want to own? Well, it's digital. So that's a digital asset. Yeah. Okay. So let's create it. Maybe it is my degree. Okay. Well, okay, what did you get a degree in? Well, let's go ahead and put those parameters in. So what are those parameters? Well, for those of you that are IT students, you know about data minimization, right? Data minimization just means we don't want to take up a lot of space that we don't have to. So we want to make it as small as possible so that we aren't egregious with our storage. So when we look here, what we see is we see things like Boolean, which is just a true false value, very easy to store. A string could be a lot of things. So it's a really kind of a big space that we're using. It allows you a lot of freedom to put anything you want in there. I'll come back to address. An integer is going to be just a number, right? It's going to be a number that is above or below 0. But if you're never going to go below 0, then you might want to use a uint, which is an unsigned integer, because a lot of times you just want to take that space that you would have been using for below 0, and you just use it for more space above 0, right? And that's basically what you're doing with a uint. And then bytes, if you're communicating, like for instance, from an IoT device or an Internet of Things device, a sensor, and you're communicating directly into another computer, and it doesn't have like human interaction, we don't have to go through Unicode or ASCII or any kind of human interpretation, then a lot of times it's better just to pass it as bytecode, because it removes a lot of problems that you might have for communication. So that's what bytes do for us. But basically what we're doing is we're just putting in what we call tuples or data points that define that particular asset. So what's important about your asset? Well, it's going to be important, maybe that you got it from University of Arkansas, right? And so that's going to be really important. So that's going to be a parameter that's going to be in here, but you're probably going to want to put this in this form because of different data sets and stuff like that. So we're probably not going to have those spaces. Sometimes they cause problems. So we'll just do that real quick. And then maybe you need to know what year. Okay, so that's going to be a string as well. And so we'll just say the year. And then notice down here, we have this thing called off-chain data. Now, this is going to be really important. And I want to make sure everybody pays attention. So please pay attention to this. Notice what's happening when I click that button. It's adding a field and it's saying it's putting a string in place. Does everybody see that? And it's labeling it bundle hash. What's happening here, for those of you that have followed any smart contract development, is we're basically doing an optimistic rollup. So for those of you that are kind of learned about like zero knowledge or ZK snarks or something like that, this is kind of the predecessor to that, but we're being optimistic. I'm thinking that the data that's being posted is okay. Well, I know where it came from because I know who posted it. It's non-reputable. I know the address from the wallet that it came from. And it's off chain because it's not going to go on the blockchain. I'm just going to take the data that it's coming from and run it through SHA-256 and put the hashed index or the thumbprint on chain. So what this does is it allows us to have non-reputable data sets, right? So the data set is non-changeable and non-reputable, right? We know where it came from and we know what it is. And so those are two really important things that a lot of times we can't have in existing workflows. So we can solve that problem with this. Okay, so now we just created an asset, but what am I going to do with it? Well, the only other thing to do with it is what is the transactions? Well, when you have a degree, the degree was issued, right? Well, when was it issued, right? Well, all the issue information about your degree, maybe that is going to be important as far as the transactions are involved. Maybe your degree has to have some continuing education credits in order to be maintained. So maybe that's another transaction that could occur with your degree. But there's a lot of things that could occur that would be part of the life cycle of whatever that asset is. So you can start to think of these as transitions to the asset if you want to, or if it depends on the asset, it could be a transaction that's actually making a state change. So if it's an automobile, for instance, and I'm selling it to another owner, then that's changing the state of that automobile, right? The owner has absolutely changed from myself to someone else. And so it's no longer my asset. So in those scenarios, then of course you would design it for that model. So let's see one that would look a little more complicated. I'm going to go ahead and go out here and show you the coffee tracker, which is the example that you're going to get. So here we see we have our roasted coffee. We're roasting it, we're bagging it, we're packaging it. It's coming in as a green coffee bean from the co-op when it comes in from the grower. And then we're putting it in bundles and tracking it throughout its process. And then after it's bagged, then, we can open up that workflow and take a look at it too. But this is just kind of a general workflow to get you guys started to understand what's happening. And then you can come in here, of course, and you can look at the different data parameters. And then once you've built the smart contract, the nice thing that's happening with our platform is all that solidity, that language that I had mentioned that you have to learn. That's this programming language that's happening right here. And our code is kind of low code, no code, right? So you just design the asset and the transaction. You got to make sure you use that very basic model. But when you do that, you're going to get the results that you're looking for. You're going to get this basic model for bringing something into a blockchain that will be tracking that state information that you think that's important. So that's pretty much, no code smart contract. Yeah, it's really kind of interesting. Now, if you're a Solidity coder, here, I'll make this bigger for you so you can see it. There's not much going on here. It's just a struct. So this is this constructor that's up here. The public is just defining like public or private. You can define who can read it. And then here we're just defining, okay, these are just method calls or, what kind of verb things can happen. And then this is, I could roast the coffee. And then this is all the data points about it. And then here is the label for those data points. So it's a very basic JSON type data structure. If you're familiar with JavaScript, this will be really, really easy kind of for you. And then the cool thing is not only does it do this for you, I like to think of the blockchain as think of it kind of like the Dewey Decimal System at the library. You look up a number and then that's where that book is over on the shelf somewhere, right? And so that's how you look at those numbers. But the blockchain can kind of be thought of as that. It's kind of an index of where I can find information and data points of what happened, when, and where, and then how do I go find it? And so here, all we're doing is just saying, well, these are things that I think I need to put out there because it's going to be important that I claim this thing, that I show that I did this thing, that I maintain compliance, that I did what I was supposed to do. Whatever it is, there's a lot of opportunities, I think, here. That you can look at. Now, the last thing that you're going to do, and I know I'm getting a little close on time, so I need to kind of wrap this up. But the last thing that you'll do with our tool here is after you've built out that canvas and you've created kind of your workflow on there, here's the beauty about that. For those of you that aren't developers, is from a developer standpoint, what we're doing for you is we're using a best practice. What we say is we create our REST-based APIs at the endpoint that the workflow is happening, and then we work backwards. So we're letting those business professionals use that tool that I just talked about to tell us what data points are important to them, to be immutable and have those characteristics that we think that we want out of a blockchain. And then we just work backwards from that, right? And so from there, that's when we would have to start. It's no longer a proof of concept. That's when we start putting in real logic. It's when we start thinking about, okay, well, what would this code call after, we have this initial asset being imported, then what do we have to do with it? How do we have to store it? What kind of decisions do we need to be making on it in the middle tier? Generally speaking, when you're building a proof of concept, you don't have to worry about all of that nuts and bolts guts logic. We're just trying to mock something up to see if it works. So what we're doing is we're generating what we call a REST-based API. And that's what this little application tab does, is when we come in here, we just click plus and we just say, hey, which blockchain do you want to deploy your smart contract on? Oh, I'll deploy it on Binance. And since we've already, and as I mentioned, we have instructions, but You can fund the Binance wallet. It's a hot wallet. It's not considered for production, but it's very easy. And then you can come in here and then you can just say, hey, I'm going to put this on an interplanetary file system for my off-chain data. And then I want to deploy that coffee smart contract. And I want to expose it at, who am I going to pick on? Let's go ahead and do Catherine. Catherine's API. So Catherine's API. And so what this is doing is Catherine's API is going to get exposed. Now, right, look at this. It's exposed at the secured socket out here at Simba chain. So we're exposing this at an HTTPS endpoint where you can go ahead and call that logic for all those getters and setters, right? That's what we're doing. And then I just unlock my wallet. I've already pre-staged this for you guys, but then I can just unlock it and then I can deploy it. Boom, and that's it, done. And it puts us out there on the blockchain. And then I'll show you. I've already pre-staged this. I did it this morning, so I've got a few transactions and stuff in there pre-staged. But let's go out here and look at one that I already got. So like here was the one. Let's do this coffee trader here. I think this is what I did. So here, when we go in here after this has been deployed, I can come in and I can interact with this, right? Here's my wallet, and then I can do these functions. I can say, hey, I arrived at the co-op. I can put those tuples in, the payment, the from farm, the green coffee bean. And then over here's the transactions in my transaction log. And if I look at it, I can actually click on here and it'll take me out to my block explorer and I can see the block, the contract that it was in and all that kind of stuff. So this is actually the actual back-end data sets that you look at on the blockchain. And then here's the awesome, really awesome part about this is, this is clunky. What I just showed you, it's clunky. Look at the method call, it was clunky. If you got front-end developers, they're not going to want to use that. They're going to be like, that's horrible. I want to have like API keys, which is what this part of the tool does. It allows you to issue these API keys. So you can say, hey, this is my React Dev 1, React Developer 1, and I'm just going to issue him some keys, and he's going to build my front-end React application for me. So I'm going to send him his keys to him through a secure email, or give it to him on a USB stick or whatever. And then when he hits this endpoint, watch this. When he comes out here and hits the endpoint, and well, actually, did I do the endpoint here? I think I did do it. This is React. So I was creating the keys on the wrong guy there. So let me do it on this guy. And so now what we can do, oops, this one, is I can hit the Simba API. So this was remember we said that we did this for Catherine. This is the one that I did previously. It's for the coffee endpoint. But on this one, this is your getters and your setters. So in order to integrate with these getters and setters, you just authorize it in your header document, which is just boom, I just put that in there. For those of you that know Swagger, that's all this is. It's just a Swagger interface. But what this does is it allows you, if you're that front-end React developer, this is what you need in order to be able to start structuring this up. Because what you're going to be doing is you're going to say, okay, when did this arrive at the co-op? And I'm just going to try this out and then I'm going to run it. Well, instead of you having to write this curl request into your React, it's doing it for you. It's saying, okay, client URL, do a get request out of that arrived co-op endpoint that you exposed it at, and then put this API information in my header because this is what we gave to that front-end dev developer. So anyway, but this is good. I mean, this is pretty much all you got to do to build a front-end web app. And then, if you got a front-end developer that you want to enhance the look and the shape and the feel, you can start to do that. Or here's a really cool point is, remember that authorizing those API keys? If you already have a system that's pulling in that data, then you just issue API keys to that system and then just have that system post that information to this endpoint for you on a schedule. And now you have an automation of posting data from an existing Web 2 application. So what do? Well, we just took this REST-based API, really simple to build, and we just said, here's the data points that we need. And we just retrofit our existing application that's really complicated. And we just said, these are the data points that we got to put on a blockchain. And that is really low hanging fruit. And you can find a lot of opportunities that are still available in that realm, I think. So, wow, here we go. I got 1 minute. So any additional questions you want to send? Full coffee tracker? Yeah, that's from Colette. So yeah, that's perfect. And I don't have anything else for you guys. So I'm going to open the floor. I apologize if I went a little over, but please, the floor is open to you to ask questions.
We're good on time, Tommy. So feel free to accept questions, as many as
Okay.
you do. We're not backed up one behind
Perfect.
the other. Just we have a little bit of buffer time, so no worries.
Yeah. So I will mention that if we do have a little bit of extra time, Catherine, is this front end piece that I'm showing you here. This is really where you're going to be able to shine, right? Because if you can find a couple, like if you find a React developer or something like that, just go out to our simbachain.com website, and we have these software development kits. So if you go over here to our resources section, we have SDKs. There we go. Yeah, so here is our documentation and our software development kits. So we have software development kits for .NET, for JavaScript, for Python, for Java. If you're wanting to do like a Jupyter notebook, we got some documentation for that. If you wanted to do like Firebase or like I said, React, we got documentation for that. And then also for some of the common truffle or some of the common tools, we also have documentation for that as well. Yeah, if you do want to upload, good question there, Chance. If you've already written your smart contract and you want to upload it into Simba, you can do that, but it's really not designed that way. If you want to do that, we have a SEP tool that really works better for that. And it actually adds in a GraphQL and interface on the back end for querying the data sets. But there's a few problems with integration with GraphQL on that tool if you don't write the program using the graph model that I showed you in the lab or in the demo, excuse me, if that makes sense.
Is that Swagger page generated automatically as soon as you launch your?
Yep. Yeah. As soon as you launch, yeah, it'll generate that Swagger and expose that API for you.
That's really neat. Thanks for doing the demo. It was nice.
Yeah, no problem. Happy to help. Thanks for attending.
Couple more questions there in the chat, Tommy, if you can see them.
Oh, I'm sorry.
It's all right.
What are examples of some projects using Simba for their applications? Yeah, that's a really great question. And can users upload? So we did the can users upload questions. So the next one is the projects. We talked about the tokes tracking and tracing coffee. That sounds pretty cool, but let me tell you a really cool one. And this is 3D printing and additive manufacturing. So the Simba company actually started because one of our founders came from a company called ITAMCO, which is Indiana Tool and Manufacturing Company. It's been around for almost 100 years. They've been building gears and parts for automobiles and even arresting gear on aircraft carriers. So they know a lot about tracking and tracing parts, and they know about sourcing parts. And so one of our first contracts was called Basecamp, and it was about additive manufacturing with a remote plant. So in the Marine Corps, I was in the aviation division, and I'll tell you a little bit about one of the problems that we ran into quite often is we would have an aircraft that would be down because we would have to order a part, and maybe it would come from General Electric or come from Rolls-Royce, and it has to come from their plant or from one of their delivery facilities. And it's a secured part, and so it can't just go through any carrier. It has to go through a secured supply chain. And so getting that part delivered is extremely difficult. With 3D manufacturing and also with 3D printing, and also knowing the source of where a document ID comes from Rolls-Royce, and where the documented ID was printed out, and it was only printed out once, digital scarcity, then I can know that that Rolls-Royce fan shroud for that AV-8B was only printed out one time, and it was done at China Lake at their airfield. And now I can actually eliminate some of those problems that we ran into with our supply chain. So that's one of my favorite stories because it actually attacks some of the problems that I ran into when I was, in the Marine Corps. So I really like that one a lot. Another great one that we're doing is along those lines, where we're keeping track of the tailhook parts and also different weapons parts and weapon systems. And what we're doing is we're tracking information about those weapon systems as they come from GuideUp, which is where all of the kind of the universal records are located, and then the different actors, which would be the Navy, the United States Navy, Air, and then Boeing, and then some of the different shipping facilities. So what we get to do is to then have insight into the location of parts when parts are needed, and then the ability to track and trace those parts and move those parts around within systems that may have a certain level of trust for one another, but don't necessarily have complete visibility of their inventory. So that's another really cool project that we're doing at Simba. And then what's coming on Simba? So I guess that's kind of the same thing. Yeah. So kind of the same. Yeah. What we're doing. I think one of the Media Verify is one of my favorite ones. It's kind of where we're doing some stuff with AI, which basically allows us to look at a digital media object, for instance, like a video file or a picture, and give you a certain level of confidence on whether or not that is authentic. And so it uses AI and machine learning and some other things involved in that. So really amazing project there too.
Well, on behalf of our team, the Blockchain Center of Excellence, and our students, what a fantastic job. I was so impressed. Just a really good intro for context. And then I loved being able to see what Simba was able to do. And I hope some of our students keep in mind some of those upcoming projects when they hear about our use cases on Friday, because it may be really helpful. So just thank you both again.